Hello students, I am Assistant Professor Dhanashree Saman from Professor Sambhajirao Kadam College, Theur. Today we will discuss about our new syllabus NP 2.0 of Shivaji University, BSc Part 1st, Semester 1st, Department of Mathematics, Paper 2nd, Calculus. In this video, we will study differentiation, successive differentiation, higher order derivatives, calculation of a nth derivative, determination of a nth derivative of rational functions, the nth derivative of the product of the power of a sine and cosines, Leibniz theorem. Example of Leibniz theorem. Successive differentiation and Leibniz theorem. Successive differentiation is the process of differentiating a given function successively n times, and the result of such differentiation are called successive differentiation, successive derivatives. The higher order differential coefficients are of utmost importance in scientific and engineering application. Let f of x be a differentiable function and let its successive derivatives be denoted by f dash of x, f double dash of x, up to so on fn of x. Common notation of a higher order derivatives of y is equal to f of x. First derivative f dash of x or y dash or y1 or dy by dx or capital dy. Second derivative f double dash of x or y double dash or y2 or d2y by dx2 or d2y, up to so on nth derivative. Calculation of nth derivatives. Nth derivative of e raised to ax. Let y is equal to e raised to ax. We differentiating this y is equal to e raised to ax. We get y1 is equal to a into e raised to ax. y2 is equal to a square e raised to ax up to so on yn. Therefore, we get yn is equal to a raised to n into e raised to ax. Nth derivative of ax plus b raised to m. M is a positive integer greater than n. Let y is equal to ax plus b raised to m. Differentiating this, we get y1 is equal to m into a x plus b raised to m minus 1 up to so on yn is equal to m into m minus 1 up to so on m minus 1 m minus n plus 1 into a raised to n into ax plus b raised to m minus n. So get m factorial divided by m minus n factorial into a raised to n into ax plus b raised to m minus n. Here are some other nth derivatives formulas. Example. First example, find nth derivative of 1 by 1 minus 5x plus 6x square. Let y is equal to 1 by 1 minus 5x plus 6x square. Resolving into partial fraction, we get y is equal to 1 by 1 minus 3x into 1 minus 2x. Therefore, y is equal to 3 by 1 minus 3x minus 2 by 1 minus 2x. Therefore, we get nth derivative by using formula 2 into minus 2 raised to n minus 1 raised to n factorial divided by 1 minus 2x raised to n plus 1. Here are some other examples of finding nth derivative. Next, Leibniz theorem. Leibniz theorem, if u and v are functions of ax such that their nth derivative exists, then the nth derivative of their product is given by uv n is equal to u n v plus n c1 u n minus 1 v1 plus n c2 u n minus 2 v2 plus up to so on n c r u n minus r vr plus up to so on u into vn. where UR and VR represents rth derivative of U and V respectively. Example, find nth derivative of x into log x. Here, let U is equal to log x and V is equal to x. Then nth derivative of log x is equal to minus 1 raised to n minus 1 n minus 1 factorial divided by x raised to n, and n minus 1 is equal to minus 1 raised to n minus 2 factorial divided by x raised to n minus 1. Applying Leibniz theorem, we get x log x n is equal to minus 1 raised to n minus 1 n minus 1 factorial divided by x raised to n into x plus n minus 1 n into n minus 1 raised to n minus 2 n minus 2 factorial divided by x raised to n minus 1 plus 0. Solving this, we get minus 1 raised to n minus 2 n minus 2 factorial divided by x raised to n minus 1. Here are some other examples of finding nth derivative by using Leibniz theorem. Thank you.